Okay, secant angles. We're looking at two types of angles today, and you're going to notice that the first one here represents two secants that intersect a circle, and they're intersecting two different arcs. Okay, that's going to be important. We're going to ultimately introduce this equation that says this angle outside A is equal to 1/2 the difference of C minus B. Okay, the same thing is going to be true for this one, only notice that sometimes we're only going to give you one of these arcs. We won't give you the second arc. You know that altogether those two arcs equal 360. So if you know B, if B was say 100, then C would have to equal 260. You can just subtract and find that. That's what we're working with today. Let's jump into this and see where it goes. The measures of an angle whose vertex lies in the exterior of the circle and each whose sides intersect the circle in 4 points is equal to the difference of the angle measures of its larger um, 4 points is equal to, half the difference of the angle measures of the larger and the smaller intercepted arcs. Okay, so that was the formula that I gave you on the previous page. We're going to jump right into this and see what we can do with this. See if it actually works out the way we've presented it. If I'm trying to find x based on what I said, remember we said the formula I gave you was a equals 1/2 of c minus b, the larger minus the smaller. So that means this is 1/2 of 82 minus 26, 1/2 of 50, 56, or 28 degrees. That's not so bad. For problem number 4, you know that the total here was 360, so 360 minus 252 gives me an 8 and a 0 and a 1, 108 degrees. So therefore, x is going to equal 1/2 252 minus 108, which is going to equal 1/2 of 144. Half of 144 is 72 degrees. We will make these a little more complicated by throwing some algebra into it, but the process is still the same. I know that 5x minus 10, the angle on the outside, is half of 13x plus 7 minus 60 degrees. Now, we don't like fractions, and one way to get rid of fractions is just simply to multiply by 2 on both sides. When I multiply by 2, that 1/2 will go away, and I end up with 10x minus 20 is equal to 13x minus 53. Collecting like terms, subtracting 10x, 10x, adding 53 gives me 3x is equal to 33. Therefore, x has to be equal to 11. All right, so that wasn't so bad. What about this one now? Again, notice that we've got 50 is equal to the half the difference of these, 12x plus 8 minus, I'm going to have to put this in parentheses, 4x plus 4, because we have to distribute that negative sign in order to get in order to collect like terms. So again, let's multiply through by 2 on both sides. That's going to give me 100 equals 12x plus 8 minus 4x minus 4. 100 equals 8x. 8 minus 4 is plus 4. 96 equals 8x. Divide by 8 and we get x is equal to 12. And we can go back and check to see if that all makes sense, but that's the general concept of what we're working with today. In summary, we're looking at several things. We're looking for patterns. So in the diagram we've got, if you remember the last couple of lessons, we've got a diagram with a theorem, and this says where does the segment intersect? Well, these things intersect on the circle, right? And we know that the angle A is equal to half the intercepted arc. Okay. Then we found out again that this is slightly different. We got a tangent secant or secant tangent. This is also on the circle. And again, we found out that A, the angle, is equal to half the intercepted arc. Okay, and those should seem familiar to you. They should look similar. The next one, we've got an angle that's on the inside of the circle. So inside the circle. Sorry, I didn't have the microphone close enough. Hopefully you guys heard some of that. The formula that we have here is A, the angle A is equal to half the sum of B plus C. And then when we got it outside, the circle, we've got the angle A is equal to 1/2 of C minus B, the difference of the circles. Now again, hopefully there's some things that make sense. On is half, inside is half, outside is half, but when they're inside you have to add, when you're outside you have to subtract. The next two are similar, again, to the last one. In this case, this is outside the circle, and again, it's going to be half of the difference, C minus B, outside the circle, A equals half C minus B. And again, those last three are all slightly different looks, but the same formula. Good luck. Have some fun with this.